These are the frequently asked questions for Algebra 2 for Section 9.2, Day 2. I'm going to start with number 17 here. It says find the 32nd term of each sequence. So the first thing I would investigate is whether or not this is an arithmetic sequence. So we have 0.1 to 0.5, which means they're adding 0.4. And then 0.5 to 0.9, adding 0.4. And 0.9 to 1.3, adding 0.4. So what I just found was that common difference. And if you have trouble finding that, you can always just take any term and subtract the previous term, and that will get you that difference, as long as they tell you that it's arithmetic. All right, now what we need to do is find the 32nd term. Well, I don't want to find every term up to the 32nd term, so that means I want to use an explicit rule. And just like we talked about in class, what we need to write this explicit rule is we need the first term and we need the common difference. Well, we just found the common difference, and the first term is right here, for goodness sake. So we have everything we need. So to find any term, you need to take 0.1 plus n minus 1 times 0.4. Now we're going to distribute from the right-hand side. So that will give us 0.4n minus 0.4. And then we'll just go ahead and clean this up by putting the n term in the front and 0.1 minus 0.4 in the back. And now we can find whatever term they want. And they asked us for the 32nd term. So we are going to go ahead and substitute a 32 in for n. And grab a calculator and see what we get for that 32nd term. So 0.4 times 32 minus 0.3. And that is 12.5. So once you have that explicit formula, you can figure out any term that they want. That's why, as I've talked about in class repeatedly, if we have a choice about which formula that we want to use, which rule we're going to use, we should use the explicit. All right, so now what we need to do is take a look at 19 through 24. And this one says we're going to find the missing term of each arithmetic sequence. And I notice that I have the term before it and the term after this, so that makes this that arithmetic mean. So all we have to do is add those two terms and divide by 2, and that will give us negative 14 divided by 2, which is negative 7. And then we can look at it and see, does that make sense? You never want to walk away from a problem without figuring out whether or not your answer makes sense. And as you look at this, to go from negative 15 to negative 7, we'd have to add 8. If we add 8 from negative 7, we do get 1. So negative 7 makes perfect sense with what we've seen. So those will all be using that arithmetic mean. On the next page, we have savings. A student deposits the same amount of money into her bank account each week. At the end of the second week, she has $30 in her account. At the end of the third week, she has $45 in her account. How much will she have in her bank account at the end of the 9th week? So what we notice here is that they give us the second week and the third week. So that means we can find that common difference by just subtracting here. 45 minus 30, she's putting $15 in each week. So that is our common difference. And then we could work our way backwards to the first week if we wanted to, and we could figure out an explicit formula for this one. However, you could just say, hey, I'm just going to keep adding 15 until I get to the 9th week. But I'm going to write the explicit rule. So a sub n equals a sub 1. Well, if the second week was $30, then she must have started with $15. And our common difference is 15. So we distribute from the right-hand side, and we notice our 15s drop out here, and our formula is a sub n equals 15n, which makes sense. If you put a 1 into it, you get $15 for the first week, a 2, $30, etc. We want 9th week. That's going to be 15 times 9. Which will be $135. So again, it always helps to have that explicit formula so you can find whatever it is they ask you for. Then this one sometimes confuses people because it says find the 17th term of each sequence. So people will go about writing the rule and doing all of that. And you're really doing too much overthinking because you didn't pay attention to the fact that they gave you the 16th term and they gave you the common difference. Well, the common difference is what they're adding to that previous term, whatever it may be. Well, the 16th term was 21, and we want the 17th term. We're just going to add a -3. That's all we're going to do, and get 18. So again, it's easy to overthink and just start checking out the formula like we usually do. But in this case, since you're only one term away, why not use that? And in 29, it's the same thing but backwards. They're giving us the 18th term and saying, hey, this is 32. Now we want you to move back. Well, to get to this term, they had to add a -4. So to get backwards, what we should do is add 4. And that will be 36. And there it is. So with this one, the 17th term is 18, and with this one, the 17th term is 36. So again, it takes stopping and thinking before you just jump right in and start writing formulas for these. Sometimes we don't need all of that. Number 33, a student claims that the next term of the arithmetic sequence 0, 2, 4, etc. is 8. Explain and correct the student's error. There's the error right there. This is an arithmetic sequence. If they're putting 8 in there, they're looking for powers because what they saw was 2 to the 0, 2 to the first, 2 squared, and they figured the next one would be 2 to the third, but with arithmetic we know it's about addition. So our addition here is adding 2. Explain and correct the student's error. They thought this was a power sequence. But it is arithmetic. So the next term is, well, we just add 2, 6. So that one little word, again, you'll find that the old English way to pronounce that is arithmetic. But to think of it, you want to think of arithmetic. So now we have their error fixed. Number 35 says find the arithmetic mean of the given terms. And we have notation here. And that notation should not drive us bonkers as long as we remember a sub n minus 1 means the term before it, and a sub n plus 1 means the term after it. So all of that notation that we see up there means just use the arithmetic mean. That's all you have to do. So we know this is 100, blank, and then 140. Well, that means you're going to take 100 plus 140, and you're going to divide it by 2. That's 240 divided by 2, which is 120. So that's the arithmetic mean. A sub n is 120. Again, you have to investigate, see what exactly it is they want you to do. Don't get all lost in the notation. Number 45 says write an explicit and a recursive for each sequence. So for 45, I will go ahead and do my explicit rule first. So I notice that my first term is -5. And then I take a second to figure out that common difference. So we have a -5 and it became a -3.5. So that would mean that they're going to be adding 1.5. So that is my common difference. And I can see that that would work in, well, any of these terms, between any of those. You could figure that out. Probably the easiest math would be on those two. And say 1 minus a -0.5 is 1.5. Now we would distribute from the right-hand side, and then we would go ahead and combine like terms, and there is our explicit rule. Now, we need recursive. And with any recursive, you have to start by giving them the first term. So your first term there is a -5. And we know we're going to use the previous term, but you know what, I think I'm going to let that be in the back of my formula and just write what it is they're doing to each term. And like we talked about, what they're doing is they're adding 1.5. So this will be 1.5 plus the previous term. And now it's done. So again, take explicit, we're going to use n in the formula. And then use recursive, you have to have this previous term notation. That's what recursive is based on. 47, explicit, a sub n equals the first term is 1. Common difference, we have a common difference here of 1/3. And you can see that right away between those first two terms when you think, what do you add to 1 to get 1 1/3? Now we'll go ahead and distribute from the right-hand side and combine like terms, so 1/3 n, and then we have 1 minus 1/3, which will be 2/3. So there's the explicit rule all ready to go. And now I just need my recursive, so let me scoot this up a little bit. Well, first term is a 1. And we already found the common difference when we did the explicit. They were adding 1/3 each time. So to find any term, take 1/3 and add it to the previous term. That's what we need to do. So once we know these and can identify these arithmetic or arithmetic sequences, it's a formula. It makes it much easier. Number 53 says, find the missing terms of each arithmetic sequence, and it gives us a hint. It says the arithmetic mean of the first and fifth terms is the third term. So here's what they're doing. They're saying, this time we're going to give you 5 slots. Here's the first one, and here's the last one. So the first thing you're going to do is use those two to find the very middle term using the arithmetic mean. So that will be 2 plus a -22 divided by 2, which is -20 divided by 2, which is -10. So that's the first arithmetic mean. We found that. Now we need to do it again with 2 and -10. So 2 plus -10 divided by 2 will be -8 divided by 2, which is -4. And now we'll do it a third time with -10 and -22. So this is just the arithmetic mean 3 times. That's all it is. -10 plus -22 divided by 2, that's -32 divided by 2, which is -16. And now hopefully we can take a fresh look at this and say, oh, look, they're subtracting 6 each time. You know, we can see that that's what's going on. So you're just using the arithmetic mean more than once on these problems. 61 says the arithmetic mean of the monthly salaries of 2 people is $4,475. One person earns $3,895 per month. What's the monthly salary of the other person? Well, we don't know, so I'm going to make that X. But I do know that if you add the $38.95 to that and divide it by 2, you're supposed to get $44.75. So the first thing I would want to do is multiply both sides by 2. And we will get X plus 3,895 equals 8,950. And then we'll just subtract that 3,895 from both sides. So 8,950 minus 3,895 is $5,055 for number 61. Number 78 says determine whether each formula is explicit or recursive and find the first 5 terms of each sequence. Alright, so I'm going to take a look at 78, and the way that I can tell is it using n in the formula or is it using the previous term? There's the previous term notation. This is recursive. The first term is a -2, and now I need to read off the formula so I can figure out how to generate the next terms, and it tells me to find any term, take the previous term, and subtract 5. So I need to subtract 5 from -2, and then I need to subtract 5 from -7, and then I need to subtract 5 from -12, and finally I need to subtract 5 from -17. And there it is. So again, we're looking for that previous term notation. That's what makes it recursive, and then we just use the rule and think our way through it. 79, I'm looking through this, I see n's. There is no previous term notation, so this is explicit. And what I'm going to have to do is put a 1 into the formula to get the first term. So that will be 3 times 1 times 1 plus 1. Well, you follow the order of operations, so this will give you 2, and then 3 times 1 is 3, and 3 times 2 is 6. Second term is 3 times 2 times the quantity 2 plus 1. Quantity 2 plus 1 is 3, so we will have 6 times 3, which is 18. Third term, 3 times 3 times 3 plus 1. Well, 3 plus 1 is 4, 3 times 3 is 9, 9 times 4 is 36. Fourth term, now at this point, we might say, hey, you know, I'm seeing what's going on here. I noticed that it went from 6 to 18 to 36, and you picked up on the pattern and you know what to do. But if you don't, then you just keep going. So, fourth term, 3 times 4 times 4 plus 1. 4 plus 1 is 5. 12 times 5 is 60. And the fifth term, 3 times 5 times 5 plus 1. 5. Sorry, a little interruption there. I'm dropping things. Very last thing I had to do, and I dropped stuff. So 15 times 6, and that gives us 90. And that will be the end of this video.